Section 8.3 is multiplying binomials. I can multiply two binomials or a binomial by a trinomial. Big ideas. There are several ways to find the product of two binomials, including models, algebra, and tables. The properties of real numbers can be used to multiply two binomials. If you look in the middle of page 498, it shows the product of two binomials as a model. There they use algebra tiles to have a physical representation of the two binomials times each other. We're not going to spend a ton of time with that, but that picture is there for you to kind of show you what they mean when they take these binomials times themselves. Anytime we're taking an x times an x or two-dimension things times each other, it can be represented with an area. So if you look at that space, the two things times each other gives us a 2D type thing, and we can see the area there, the two-dimensional shape. In example 1 here, we're going to use the distributive property. We want a simpler form of 2x plus 4 times 3x minus 7. So when we look here, we're going to use distributing. I like to call it double distributing because we're going to have to kind of do it twice here. We're going to take the first term of our first parentheses and multiply it by our entire second polynomial. Then I'm going to take the second term of my first polynomial, that binomial there, and multiply it by my second binomial. So I took the 3x minus 7 to the 2x and to the 4. Okay, I took 3x minus 7 times 2x, and I took 3x minus 7 times the 4. Now, this is where the double distribute comes into play. I'm going to take the 2x and multiply it into both pieces of my binomial. And I'm going to take the 4 and multiply it into both pieces of my binomial. So here I have 2 times 2 is 6. X times x, add our exponents, x squared. 2 times negative 7 is minus 14x. 4 times 3 is 12 times an x, and 4 times negative 7 is negative 28. So again, I took my 3x minus 7 times both things inside my parentheses, 2x and 4, and then I took each of those and distributed them into the parentheses. Our final steps then are to combine any like terms that we have, and make sure it's written in standard form. And here it is. There's nothing else I can combine. I have a quadratic term, a linear term, and a constant term. They're in decreasing order, and all like terms have been combined. Now here we're going to do the same thing. I'm going to take my entire polynomial, my second one there. I'm going to multiply it by everything inside my first polynomial. So I'm going to take 4x plus 3 twice. The first time, I'm going to multiply it by the x. The second time, by the negative 6. Now, I'm going to distribute again into my binomials there. X times 4x gives me 4x squared, and x times 3 gives me 3x. I take that sign with my number and get negative 24x. And negative 18. So again, here's a double distribute. I took my entire binomial, something outside my parentheses, and multiplied it by everything inside. So I took 4x plus 3 times x and 4x plus 3 times negative 6. Now, I have to distribute again to get rid of the second set of parentheses. I'm going to take what's outside times both things inside. What's outside times both things inside. We're going to combine our like terms. And that is our simplified form of our polynomial here. In example 2 here, we're going to multiply using a table. So when we use a table, set up our table here, and remember that we're multiplying. In my first polynomial, I take my first term and my second term there. Okay, they each go in their own column. My second polynomial, I take my first term and my second term. Remember, the signs go with your numbers there. Now, each square here, or each box, we're going to fill with the sides that touch it. So here, I'm going to take x times 4x. I'm going to get 4x squared. I'm going to take negative 3 times 4x, get negative 12x. Here, I'm going to take x and negative 5, and get negative 5x. Here, I'm going to take negative 3 and negative 5, and get a positive 15. Now, I take all of the boxes on my table, 4x squared, minus 12x, minus 5x, and a positive 15 means plus 15. And just like we did when we double distributed, we had our 4 terms. Combine any that we can. And make sure it's in standard form. So again, the top of my table is one of my binomials, x and a minus 3. The side of my table is my second binomial, 4x and minus 5. We're multiplying here. So kind of like Punnett squares in biology, we're going to take x times 4x to fill this one. We take our row times our column times our row to fill this square. Column times row and column times row of where the box meets. Then we combine our like terms and get our simplified answer. Now, feel free to pause here and give this a try if you'd like. What is a simpler form of 3x plus 1 times x plus 4? Again, we're going to set this up with a table. So I'm going to take 3x and 1, and then I'm going to take x and 4. It doesn't matter which binomial you put on the top and which one you put on the side as long as you're consistent. So if I put the 3x on top, the 1 has to go with it. If I would have done x on top and 4 on top, that's fine, but the 3x and the 1 then would have had to go on the side. Doesn't matter how we set up that table, as long as we keep our polynomials together. Here I'm going to take 3x times x, because that's the row and column that meet in this square, and I get 3x squared. Remember, x times x, 1 times 1, x to the first times x to the first, we add those and get 2. I'm going to take 3x times 4, 12x. 1 times x just gives me x. You can put the 1 there if you want to, but we don't need it. And 1 times 4, 4. Now I have a 3x squared. These x's I can combine, so I have 1x plus 12x, which is 13x, plus 4. In example 3 here, we're going to use FOIL. What's a simpler form here? FOIL is just an acronym that we're going to use here to help us remember the combinations of things to multiply. So FOIL stands for firsts, outsides, insides, and lasts. What we mean by that is firsts from each binomial, outsides, the outermost terms in each binomial, insides, the innermost terms in each binomial, and last means the last one in each binomial. If we look here, guys, we never multiply something from inside one binomial with the other term in there. It's always with the other one. And just like we've been doing before, that is the case. This is just a shortcut. So we can double distribute, and that's essentially what we're doing. It's like if we set up a table as well, but here it's just an acronym that helps us remember which things to multiply when. So with my FOIL here, my firsts, 5x and 2x. And again, we're still just multiplying. I'm going to take 5x times 1. I'm going to take negative 3 times 2x for my insides. And again, the sign goes with the number. And I'm going to take negative 3 and 1 for lasts. Here, 5 times 2 is 10. Multiplying power, same base, we add our exponents, x squared. 5 times 1 times x. Negative 3 times 2 is negative 6x. And negative 3 times 1 is negative 3. Now, we're still just adding all these together. So I'm going to have 10x squared. Here, I get minus 1x. You can put the 1 there if you want to, but again, we don't have to. Minus 3. So I get 10x squared minus x minus 3. And that's our simplest form. All of our terms are combined that can be, and it's in standard form. To find the simpler form of each product here, again, we've done 3 different ways. I'm going to do this one by foiling. Remember, firsts, outsides, insides, and lasts. And the sign goes with the number there. We're going to actually do our multiplication, 3x squared plus 6x minus 4x minus 8. Positive 6 minus 4 minus 8. Combine our like terms here. 3x squared plus 2x minus 8. We can look for patterns here. Again, we should make sure we use every number exactly twice, or every term exactly twice. So I have 3x and 3x, negative 4, x, 2, 2. And those will go in the same order every time. So it'll always be our first, second, third, fourth terms. In B here, again, feel free to use any method you want. Doesn't matter. I'm going to FOIL again, and I'm going to do it in just a little bit different format. I'm not going to write out my acronym. We still can if you want to, but we don't have to. So firsts, outsides, insides, and lasts. I still like to do these different like shapes or squiggles or whatever underneath my numbers as I go, just to make sure that, yep, I have 2 of those, 2 of those, 2 of those, 2 of those, and nothing within its own binomial. I used every number exactly twice, and I can still track it that way. If you feel more comfortable writing it out like we did up here, then go for it. But if you think that you're pretty confident and want to just multiply right away, that's acceptable as well. We're going to combine our like terms here, minus 31n, and bring down everything else. So 4n squared minus 31n plus 42. On the last one here, I'm going to set this up as a table just to get a little bit more practice with that. You can FOIL here. You also can double distribute if you'd like. So I'm going to do 2p squared plus 3 and 2p minus 5. Take that sign with the number. When I multiply here, I take 2p squared times 2p. 2 times 2 is 4. There's a 1 there. Add your exponents. This is p cubed. 3 times 2p, 6p. 2p squared times negative 5 is negative 10p squared. And 3 times negative 5 gives me negative 15. If we look here, I made sure to mark when I used each of those, and we used them each twice, just like we do when we FOIL. This is just a different way to help you keep things organized. Now we're going to put these in order, standard form. I have a 4p cubed minus 10p squared, positive 6p, so plus 6p, and a minus 15. And there's nothing we can combine there because the number of variables are exactly the same. They're all p's, but they're all at different degrees. 3, 2, 1, and none. And so that's all the further we can go there. I'm going to stop here and finish with another video.